Welcome to this IHS Industrial Process Equipment and Automation online event. Many engineers spend nearly half their time on non-value-added tasks. These may include searching for information, repeatedly entering the same data into different systems, or manually performing complicated engineering calculations. Now, before this presentation, we'd like to invite you to submit questions at any point during the presentation by using the Submit Question button at the base of this video console. Also, some of the presentations you will see today include detailed information, so we would encourage you to click the Download PPT button so that you can follow along with your own copy of the PowerPoint slides. As Manufacturing Solutions Team Manager for IMAGINiT Technologies, Caleb Funk has particular insight in diagnosing manufacturing workflows. His expertise regarding data management and product lifecycle management solutions has helped many companies achieve significant process improvement, particularly in the manufacturing and electromechanical engineering industries. Caleb, welcome to today's event.
Thank you, and good morning or good afternoon, depending on your time zone. Today we've got just a little bit of time together, and there's a few things I want to cover. One thing we're going to take a look at is the idea of engineering productivity today, kind of where we are. And it's been really interesting with IMAGINiT, having spent the time there that I have and being in the different companies that I have. We've been able to see a lot of different ways people do things. I also want to take a look at mapping out engineering processes, looking at the processes in a current state and a possible future state. And I want to talk about some success stories. And these are real companies that we've seen that have benefited by improving their processes and working with this information. Before I get too deep into that, I do want to tell you a little bit about IMAGINiT. IMAGINiT has 20 years of experience in this particular industry, working with engineers, working with architects, working with civil engineers, people across the board. We have a very large staff of technical experts, and this is where I live, is in that area. I come from an engineering background, and I work with these guys every day, and that's one of the biggest things about the company. Is one of our strengths is that depth that we have within there. We've got 45 North American locations, and this just kind of gives you a broad overview of where we are, the different places that we exist. Obviously, we're heavily in the eastern area of the U.S., and that's where I call home. Ohio right there is one of those pins that I have. That's my office. So what I wanted to start with, though, even before we look at some of these processes, is the idea of weekly planning meetings and what goes on there. And these are some of the things that typically come up as part of this. And it's always the questions of how do we deal with these type of things over and over is what we're hearing from customers. Dealing with this workload that we have with fewer resources. And of course, everybody wants something faster. And we need to cut costs, so we need to have less rework and less scrap. And at the same time we're doing that, what we want to do is have new product development. We want to innovate so that we're not creating the same old thing that we have for years, but we've got new ideas and new products to offer. And we're going to do all of this without hiring anyone else. So this is really typical that we would see, and these are real questions that need to be answered. Companies will gain market share. Companies who make sales easier to win, companies who reduce costs, refine their processes, these companies will gain market share. And this research is from a group called Aberdeen. This was a study that was done where people went through and looked at this and understood that these types of things, processes, is where it really is. So as we take a look at companies that fully leverage technology, and I think that's an interesting phrase, fully leverage. But these companies work faster, work more efficiently, and make more money overall. It's that idea of fully leveraging that, really dealing with what you have, really getting into the technology that you have, maybe even more than buying new technology that begins to make the difference. So we have all of these questions to answer, and really you can't be satisfied doing the way you did things before. You have to stand out from the crowd. You know, I deal with industries in Toledo, Ohio, where I'm from, and it seems like so much of it is based off the glass industry. So there's all these glass companies doing very similar things. And you have to stand out from the crowd to really begin to build your business. And you have to embrace one-of-a-kind ideas. So when we look at this idea of what can we do to improve things, and I've got this up, this was something that stood out to me. To be competitive, to win business, to deal with all these different types of things, Typically, what we had is we would train our people. That would be one way. That adds to our competitive ability. We've got some of the best trained people. We also look at tools, and that's the software ingredient that I have there. I started in this industry a while back. I've been working with tools like AutoCAD and Inventor for years and years now. AutoCAD, I go back to 1997 working with it. And back then, you could just have a particular software tool and say, well, here, this tool is available. We're expecting X amount of productivity based off the tool that we've given you. And now that we can use it, let's go there. But that missing ingredient, the thing that we really don't have in here, that we need to have in here, is working with processes. So, real quick question, kind of a pop quiz that we would have right here. And this is something that I've seen a couple of times, phrased in a couple different ways, but it comes down to this just basic idea. On average, how much of each hour is productive? Now, I do want to make one small distinction here, not the idea of busy, because believe me, all 8 hours are busy. I think we're all familiar with that. We're all aware of that. We take that time, there's always something happening. But real productivity, and that's a different question to answer. How much am I actually being productive? And a lot of times that would not be so much spending time, doing my job, but spending time creating the core functions of my job, working through those pieces. Well, what we've found for a lot of people, only 15 minutes per hour is productive. So we're looking at 25%. For some people, this gets as little as 5%. Now, that's kind of a shocking number, really. When I first saw this study and saw this information, I thought, there's no way. I just think of myself personally, the amount of time I put in each day, the amount of time I'm actually busy and doing things and going through, there's no way. Then they started looking at some of the reasons why this was true. If we're talking about engineering, up to 75% of an engineer's time is looking at non-value add tasks. So we're not innovating, we're not even really creating. What we're doing is we're looking for design data. We're going to find that file that I swear was there. Which drive did we put it on? Was it in this folder? Building bills of materials, setting something like that up. Again, going through with a highlighter, making sure I've got everything highlighted. Do I have every component that I need? Checking it off as we go. Creating documentation that's part of that. And then the simple one, and this plagues everyone, putting the same information in over and over again. Sometimes it's not the same person doing it each time, but as this gets passed through the company, we'll see where the next person has to re-enter the same information. Maybe it was in a bill of material, now it needs to be in a spreadsheet, and now from the spreadsheet we need to pass it over to an ERP system. It's these types of things that really do drain productivity, and they take that time away from us. So I got another question. This is kind of part 2 to the pop quiz that we would have. And as we take a look at this, it's a really simple one. And when I saw this was just a great analogy. When you leave the fast food drive-thru, do you check the order? Or do you just drive off assuming everything is fine? Most people are going to take a look. They're going to look in the bag just sitting there. Okay, here's my fries, here's my Coke, here's my cheeseburger. It's all here. And the reason that we do that is really simple. You can't afford to make a return trip. No one wants to turn around and go back through and sit in the line again and say, you know what, the second cheeseburger isn't here, or the kids' chicken nuggets aren't here, whatever it is. So it's a simple thing. It's a part of a process that you have in place to make sure that you don't do that. But what's interesting, in a lot of companies that we see, 1 out of 3 is in the fix-it factory. They're picking up mistakes as they've gone through. They're entering information in again, or they're correcting wrong information as it goes through. So it's the time spent in these areas, and this is a broken process is what it comes down to. It's the time spent in these areas that are pretty impressive. This is where we see that 75% of non-value add time. So what we want to do is optimize that. We want to make it hard for a new employee to make a mistake during assembly. We want to make sure the product is set up in such a way so that it cannot be designed incorrectly, whether it's through configurations or options or different choices. Or maybe it's a website issue. Maybe it's all at the front end where we're dealing with when people are putting information into a website, the order doesn't come through correctly, we don't have the right information. These are the types of things we want to look at to begin to optimize. So my goal for today is to get you thinking about your own process improvement ideas. What areas stand out as things that you could do and that could be beneficial? So where do I start? This is always the question when we look at something like this. There's so many variables, there's so many pieces to a puzzle, particularly when we're looking at manufacturing, where it starts from order entry to when it finally rolls out the shipping dock. What do we begin to look at? The first thing you should really do is review the whole process. And I just mentioned a really simple one, it starts with a sales order and then it rolls off the shipping dock. What happens in between there? What really happens? How does it go through that particular order? Do we start over here in sales and we get information in and then we send it out the other, then from sales, maybe it goes to someone to do a general arrangement. What does that look like? It's interesting, in the companies I've been in, I've seen this very widely. I've seen it from very configured information where it's very set and it's always the same, all the way up to where it's the spec that we get to start out with is make an ice cream bar that looks like this. All the rest of the design is up to you. So documenting that and understanding it is important. Now, one mistake that's easy to make when you're doing this, particularly if you come from the engineering world like I do, is you will focus on engineering. All you're going to look at is just the engineering portion and look at the tools and things that you maybe need within engineering, look at the information entered within engineering and how you need to pass that along. But we need to look beyond that. We need to look into a few different areas. So we need to look at the whole picture. And this is what a process review that IMAGINiT did for a recent customer. Process reviews are something very commonly that we would do. We would work with the customer, maybe doing interviews or research into their company, discussing with the different stakeholders that we would have as to how they would want to work with these different tools. So this is something that we found. Looking at this one, we found one issue within sales. So we're not even looking at engineering at this point, and we have all these RFQs going through, and realistically, we're hitting maybe 60% of them. So we're not responding to everything that we could. That's business that is potentially lost because we can't get back to these, because we're not getting back. Now, we did find something within engineering, so shop drawings took a while. Once we got to this point, we've got 4 or 5 days to put this information together. Is there any way we could look at that? That really does seem to be a bottleneck that we would have and something that we would need to work with. Entering bill of material data, and this is such a common one. I see this over and over again, where putting the bill of material data in, whether it's to an ERP or spreadsheets or re-entering it for purchasing, this is taking up to 2 hours. So out of a 4 or 5 day process, just for creating the drawings, we've got an additional quarter of a day taken up just in the bill of material data. And then finally, we were finding that based off of bad data or missing data or prints that were out of date, there was a lost production of 35 to 40 days per year. So there's a lot of different things wrapped up into this single process and a lot of different things we may want to take a look at for working with. But what we need to do is we really need to look at the 450 rule. And this is a concept that comes from a lean manufacturing book from Six Sigma. And the idea is, it's not just 80-20. And that's what you hear a lot of times. It's an 80-20 rule. It's a lot of times 450, where 4% of your processes can represent 50% of the inefficiencies. It's worse than you thought. If we can clean these up, we can gain things though. And that's what we really want to look at. The key is to find them and then to focus on them. We want to be able to look at this information, see it clearly, and decide what to do about it. So, how can we improve the process? Let's say we've gone through and we've mapped that out. We now see the problems that we've had in the past. We kind of mapped where the bottlenecks are, and we say, gosh, this RFQ thing needs to be looked at, or we can't spend this much time reworking these drawings or entering this bill of material. So I wanted to talk a little bit about some real-world examples of different companies that we've worked with who've spent time doing this and have gone through this process. So one customer that we had is Belvac. They deal with heavy machinery. So what they were looking at, they had a 20% improvement moving to 3D. But one particular part of their process was what they called a constant velocity path. It was really how these items moved through this machine. And this was something that was difficult to figure out, and there was one person in the company who knew how to do it. So And nothing could be done until this path was understood. And this took 5 to 7 days to complete. So every project that we have is going to go through one person, and it takes that one person 5 to 7 days. You get 2 projects, 10 to 14. That's the lead time that we're looking at for this type of thing. So what IMAGINiT was able to do is we were able to spend time with them, map the process, understand the rules and how it worked together. And then we were able to take that, build rules about it, build information into it, and turn it into simplified rules. We took that engineering information, simplified the process where it can be captured, and now any member of the staff can drive it. So already we've expanded out because it's not just one person, but now it's everyone within the engineering team that can work with it. We took that 5 to 7 days down to 5 hours, and we're able to spread that out among multiple people who can work with the tool. And that's just one example of some things that we work with. Process automation isn't just in that engineering department though. It really covers a lot of different areas. So to give you an example of some of the other things that we might be taking a look at, some of the other tools areas we might want to look at and tools we might want to access, is it could be some simple drafting tool automation. This would be something, just simple toolbars, speeding things up. I want some particular design to be faster, or I want some particular tool to be faster as we take a look at it. Some different information like that. This is something that we saw a lot of years ago, taking maybe simple 2D information and just making the process faster overall. 3D design automation is definitely something that's really hot right now. A lot of customers are working with this. A lot of people are dealing with it. In this example here, we've got a conveyor. And this conveyor has options. Maybe there's a motor on the left side or the right side. It has particular idlers or rollers or whatever else it would be. And then what we would want to be able to do is capture that and then automate it so we're not redesigning every single time. And that's very common. Integrating that information, integrating what we see, whether it's from 2D or 3D, into tools like Epicor or SAP, any ERP system that you might be working with, taking that into the PLM system down the line. That is another area that we can work with that information. Take data from a CAD model, take data from a data management system, and then push it to some extended business system tool. And another big area is the idea of sales configurators, where I've got information. It's kind of the same, except it's a little different. We want to be able to set this up so that we've got it in multiple people can enter this information and see how this fits together. That's how we would want to set this up. So just a few examples of some of those things and how they work. This is what speeds things up. This is what changes. We can improve within time to market. We can get these things out faster. We can decrease cycle times, which really is about decreasing cost. If we can do it in less time, if we have less engineering time spent on something, then we have less engineering cost built into something. So there's a lot of different areas that can work with. Quality overall can be improved if we have fewer errors or fewer omissions. We just forgot to put that information in. Or dealing with that manual data entry. That just seems to be such a thing that comes up again and again, where people are entering data multiple times in multiple locations. And another one that's really interesting is the idea of configurations, where we could do numerous or multiple what-if scenarios, kind of laying out general arrangements or looking at a particular, whether it's a layout or an assembly or one particular product, and being able to make adjustments to it on the fly. So all of these different things come together, and really that's what changes the processes. And we've done this. We've seen all of these really take off and really be beneficial. One, and this is kind of a simple area that we were looking at, it's kind of a simple fix really, this was a heavy mining equipment manufacturer. And so the assemblies they were working with were large. These were big components. We had 10,000 pieces as part of this. And when they would go to open this, it would take literally 2 hours. So they hit there, they click open, you might as well take a meeting, go get a cup of coffee, productivity is done. And of course, everyone hates to wait on a computer and you're just sitting there, see the status bars go by. So this was just killing productivity. It was killing morale. It was just frustrating all around. What we were able to do was review their process. We tested model standards against specific rules. We looked for items maybe that hadn't been fully defined. We looked for items maybe that conflicted with one another. And out of this 10,000 parts, 900 plus failed. So nearly 10% of them had some sort of issue, some sort of problem that we were dealing with. Once those were through and we cleaned those up, this whole thing opened in 3 minutes. So, we were looking at that 450 and the amount of time we can gain looking at something like that. To be able to go from 2 hours to 3 minutes, it's literally life-changing. You can barely have time to get your coffee and get back now once that thing is open. The productivity gained just from this simple thing, and again, this is a process fix. This isn't a automation yet at this point. This isn't radically changing what we do. It was fixing a process that was broken. Another example of something that we ran into, and this is a little different. So here we have smaller units that we're dealing with, but what's going on is we've got HVAC systems, and this company is called Danco. So they've been growing and growing, and they've got these components have all these different variations they could work with. Literally hundreds of them based off of the different items going in and the different variables that we could work with. So we've got a product with hundreds of different possible ways we can set it up. We're going to use multiple products on any particular project. We need a 27-sheet drawing set. So we need to go through, create the 3D model with the different variations, and create the drawing set as well. This was being done in 3D, and they were realizing the benefits of 3D. So they were beginning to see how this is improving and we can create these drawings. But what we need to do is create dozens of units sometimes for these buildings, and we don't want to hire anyone new. There's that refrain again. What can we do with the tools and the people that we have? Well, what we were able to do is go in and work with this particular tool. Again, we took it from that 2 to 3 days. We were able to drive it using some iLogic code. Essentially, it's a configuration tool that we were able to set that up, create assemblies, parts, drawings for each configuration that we would have, connect it to an ERP tool, and we were able to take it from that 2 to 3 days down to 30 minutes per unit. So now, it's not 2 to 3 days per unit, it's 2 to 3 days for all units needed in a building. And it's that type of configuration, it's that type of process automation that really makes a difference with these tools. Another example that we have is prefab steel buildings, and we've got a lot of information that we need to capture for each order. The actual documentation isn't that bad, that's taking us a day, but we've got a manual process to build the details, we've got all this information to capture the order, and this is something that, what can we do? Because this seems to be the same over and over again as we go through. So we were able to take this information, set it up so that we had faster drawing production, a bill of material export, and we were able to take that shop print package and generate it automatically as part of this. So now we can produce 20 AutoCAD drawings in 30 minutes instead of 8 hours. We took that from a day down to 30 minutes. So we're capturing as much of that information on the front end as we can and then sending that out as we go. Here's another one. This was really interesting. This is a playground manufacturer. And to begin a layout, to begin setting up some type of information, whether it's for a local parks and rec area or some other municipality, they would have a 2-week turnaround time on approval drawings. And there's an example of their approval drawings that I can show here. And what this looks like is it's difficult to see. I mean, I kind of get an idea, but I don't read playground prints every day, so I get an idea. So it's pretty limited visualization that we're working with. Estimates didn't always match the drawings. Once we got these drawings through and we got them set up and we're doing some estimates and maybe there was something missed. Again, there's that idea of going through with the highlighter, trying to check everything off and see where we're at. But sometimes estimates didn't match up to the drawings. So we needed a way to help them take this process, make it more visual and more precise. So what was created was a sales configuration tool. And this almost works like little snap together bricks. We can take this information, take configurations, take components, and begin snapping it together to create this general arrangement, the initial layout. Only this time the general arrangement isn't a 2D overhead plan view. Now we've got a full 3D model. The visualization just is unbelievable now that we can see all of these different pieces and how these fit together. But we didn't stop there. To also generate project drawings, bill of material, and then the project documents needed to create all of this information, assemble it, construct it, manufacture it. Every piece is there. So this took a significant time difference. This was something that really took what we had here, simplified it, and made a significant difference within their company and how they're doing things. So I wanted to talk about, just prompt you with that idea of how we can set this up and how we can bring all these pieces together. And there's two ways that we can work with this. There's the ready, fire, aim option. And unfortunately, this is what we see so many times. You find an area of concern. My gosh, it's taking us 3 days to generate these drawings. We need to fix that. Let's get some software in here that's going to help with that. Or, realistically, the old version used to be, let's hire some more people to help with that. Now it's, what software can we buy to help with that? Let's get this software in, let's work with it when we can so that we've got it set up and maybe we can spend some time with it. And I'll task Caleb over there in the corner when he has a chance. He's really going to figure that stuff out, and hopefully that'll work out for us. Surprisingly, this does not always work out for the best. So what we found is we've got a pretty systematic approach that we can go through, take a look at where we want to go, map it out, and then based off of that, use the right tools to get there. So your homework, what you need to take a look at, what I think would be very beneficial to take a look at. What are the 4% for you? The biggest bottlenecks in the process that you're dealing with. And again, don't just think it out. A lot of times, whatever you're closest to seems to make sense. Don't just say, you know what, it really feels like, map it out. Take the time to go through and look at that. Ask yourself which repetitive or manual tasks are not adding value. Which of these are getting in the way of getting this stuff done, not actually getting this stuff done? Where's the biggest opportunity for errors? And I will bet, just a guess, it's re-entering data. Whether it's information from sales, moving to engineering, or engineering moving to manufacturing, anytime data has to be re-entered or re-keyed, really anytime data is handed off, that's where a lot of errors come in. And a final area to think of is, how does this affect people outside of engineering? I had that one slide up earlier where I was pointing out how we don't want to look just at the engineering portion, but really look outside of that. Because a lot of times, changes made there will affect people throughout the company. So we really have to look at that as a whole. So that's what I wanted to do today. I wanted to go through and really get you thinking about these ideas and thinking about these concepts. Now, one thing that I've noticed is, I've done this presentation several times, and every time I do, it seems like I've brought up more questions than I have answered questions. So if there's any particular questions, I'd love to go ahead and answer them.
Okay, Caleb, thanks for that great presentation. We do have some questions from the attendees, so let's get right to them, shall we? The first question asks, is this type of automation expensive?
It really depends. It varies greatly. It depending on what we're automating, exactly what we're doing, the number of tasks, what kind of data we're working with. So there's it really does go up and down the board. The thing to think about, though, is the return on investment could be up to 90% or reduction of effort or more. You look at some of those things that we had where it literally dropped from going from 3 to 5 days to 30 minutes, which is more expensive.
Okay, next question up. Does IMAGINiT provide services to help us identify those areas of our workflow that could be improved through automation?
Definitely. And I mentioned this just a little bit during my presentation, but I'm part of the consulting services team, and we've got engineers and application experts who are just focused daily on assisting people with that discovery process. And that's what's really essential to that first step, but that's definitely a large part of what we do, and we'd love to help you with that.
Okay, Caleb, here's another question. In the presentation, you discussed integrating with ERP systems. Have you worked with Epicor?
Absolutely. You know what? We've worked with a lot of different ERP systems, Epicor, SAP, Made to Manage. Each system has a different custom application that will need to connect to that. So there's a different way of doing each one. There's not just one tool that does it all, but absolutely. We've pushed information to a lot of different systems.
Okay, here's another question. Is this type of process automation a locally installed application, or could it be run over the web?
It really depends. It could be leveraged either way. Some companies have collaboration that has, just geographically, we've got these really big distances that we need to work with. So we want to leverage a web app. Some, maybe you've got one location, so it's just, we want to run all of this automation internally. So it can be done either way. It largely depends on your specific circumstance. And again, that's why we go back to the idea of doing that process to really understand what we need.
Okay, Caleb, we've got time for one more. Many of the solutions discussed are tied to Autodesk software. We use Solidworks for our engineering system. Would you still be able to help us?
You know what? Absolutely. Depending on what type of solution is required. Yes, a lot of our expertise really does tie to Autodesk software. It's kind of our home base. But a lot of these different automation solutions are not CAD dependent. Pushing information to Epicor is a lot of times something like that may not depend on CAD at all. Being able to have a configurator may not depend on it either. So it really depends on the type of solution. Ask us, we'd love to help.
Okay, Caleb, those are all the questions we have for now. We'd like to thank you for sharing your time and your insights with us today.
Thank you.
Now, before moving on to explore the exhibit hall of this event, please take a moment to click the Take Survey button and let Caleb know how he did today. Your feedback helps us improve the quality of our IHS Global Spec events, making them an even better investment of your time. Remember, you can see any of today's presentations during our on-demand period, but exhibitor representatives are only here on the day of the live event, so spend time with them while you can. Please experience our latest innovation, the Knowledge Exchange, offering product demonstrations and our Hot Topic podcasts. The Knowledge Exchange is also home to our Event Price Center, so make it a point to visit. Share your thought leadership point of view by speaking at one of our events. You can find the speaker submittal form at our event help desk in the exhibit hall. Well, we'd certainly like to thank you for choosing to spend your day with us, and we'll see you back here in the conference center a little later on.